Deepseek is a Chinese artificial intelligence company founded in May 2023. On January 20th, 2025, the company released a new artificial intelligence model called R1, and it caused a shockwave around the world. Because unlike OpenAI's ChatGPT, which costs billions of dollars to train, this new AI was developed with far less money. Moreover, in benchmark tests that allow us to measure artificial intelligence performance, it managed to achieve scores as high as ChatGPT's top model, O1. The crazier part is this: because of the United States embargo on China, none of the Chinese AI companies are allowed to buy NVIDIA's H100 GPUs that are specially designed for artificial intelligence. To understand how important this is, consider that OpenAI needed thousands of these GPUs, each costing around $25,000 to develop ChatGPT. According to reports, Deepseek managed to surpass OpenAI without using even a single one of these GPUs. In addition, unlike OpenAI, the company Deepseek announced this new artificial intelligence model to the world as completely open source. This means that unlike OpenAI's models, you can install this model on your own computer, access its code, and use it however you want. Deepseek has practically taken over the mission that OpenAI abandoned when it transformed from an open-source AI foundation into a closed-box and profit-driven company. Deepseek showed that, unlike OpenAI, it is not necessary to be a closed box in order to succeed. The rapid spread of this model shook the American stock market on January 27, 2025. NVIDIA, the chip supplier for all AI companies, lost $560 billion in a single day, breaking the biggest one-day drop in financial history by a huge margin. The previous record also belonged to NVIDIA. On the same day, the American stock market lost over $1 trillion in value. After this, OpenAI claimed that Deepseek had trained its R1 model by stealing OpenAI's own models, and that it had evidence to prove it. But this is quite a funny claim because OpenAI trained all of its own models using articles and online sources uploaded to the internet without permission and without paying for them. Immediately afterward, a claim emerged that China had purchased H100 GPUs through Singapore. As you can see, things have become extremely heated. So how did Deepseek manage all of this? Let's examine all of it. First of all, we need to understand how artificial intelligence works. You have probably heard of deep learning, which is a very popular term. What we call deep learning allows artificial intelligence to learn and process information just like a human brain. Think of it this way: there are billions of neurons in your brain, and each one is connected to another. For example, when someone says a word to you, associations related to that topic appear in your mind. In fact, what we call artificial intelligence is basically an imitation of the human brain. These kinds of artificial networks look like the one you see on the screen right now. You can think of the circles here as neurons. The green neurons are the parts where information enters the system, similar to our sense organs. A stimulus comes from the outside, and some of these neurons become activated. The lines in the visual represent the connections between each neuron. Although it is not shown here, as you can see in this other visual, those lines actually correspond to a certain multiplier. These multipliers, which take values between 0 and 1, represent the strength of the connection between the two neurons. The closer the multiplier is to 1, the stronger the connection, and the closer it is to 0, the weaker it becomes. And these coefficients are assigned completely randomly at first. The numbers on the neurons are actually the result of a simple mathematical operation. Each neuron multiplies the numbers coming from other neurons connected to it by the weight of the connection between them. And then it adds a number called bias on top of this multiplication. This bias number is used to adjust the activation threshold of each neuron. Of course, when we perform these operations, we do not obtain a number between 0 and 1. To achieve that, we use a simple function called the sigmoid function, which converts the result into a number between 0 and 1. In summary, each of these circles is simply a unit that stores a number produced through basic arithmetic, resulting in a value between 0 and 1. If the information coming out of the system is incorrect, you tell the system that this is an error, and the system updates the multipliers that determine the strength of the connections. Finally, when you tell the system it has done it correctly, the system keeps and saves the numbers in those multipliers. Let us not forget, if we want to make these neural connections more complex, we can add more neurons and more layers. In fact, we can add even more, and in the end we could obtain a neural connection map large and detailed enough to copy the brain of a living organism. So how does this system manage to learn things? For example, when I show you letters written in different styles but meaning the same thing, your brain instantly recognizes all of them as the letter A. Now, how would you give this ability to a machine? One thing you could do is use a method called boundary recognition. You can take a handwritten letter or number, like the number 3 shown here, place it inside a box, and assign each pixel in that box a value between 0 and 1 based on its brightness. If a pixel corresponds to pure black, we assign 0. If it is pure white, we assign 1, and if it is any shade in between, we assign a value between 0 and 1. Now, our goal is to detect which handwritten number a given pixel pattern represents. If we can do this, we will have taught the machine to read handwriting. To do this, we need to use all of our pixels as the input to a neural network. If the box that fits our numbers contains 28 rows and 28 columns, then the input layer of our neural network will consist of 784 neurons, which is 28 squared. The final layer is the output layer, which contains numbers from 0 to 9 that the system will give us as its answer, because in this example, what our network needs to learn is to distinguish the digits from 0 to 9. The two layers in the middle represent the layers that will be trained to identify certain features of the handwriting. The number of neurons in these intermediate layers and the depth of the layers are completely arbitrary choices. Traditionally, two intermediate layers like the ones here are used, and we call them hidden layers. If the number of these layers goes above 3, we call that system a deep neural network. And that famous term, deep learning, comes exactly from this number of layers. In short, after the mathematical operations performed through the network and the feedback you give to the system, the network selects the most accurate number from the output layer on the right. But remember, each of the output neurons gets activated to some degree, and the system simply chooses the one with the highest activation value. By the way, if you want to see the three-dimensional form of this network, it creates an amazing structure like this. The most important factor that determines how much our AI can learn is big data, because an AI can only improve based on the information it is given. In other words, a predefined dataset prepared by humans that will be used to train the AI. As you know, on some websites, Google gives you a test called CAPTCHA after you click on the "I'm not a robot" option. Those handwritten texts or images you are asked to identify in those tests exist thanks to pre-prepared datasets. And the cleaner and more diverse your dataset is, the smarter and more accurate your AI becomes, just like the difference between a person who has read one book and a person who has read 1,000. Now that we understand how artificial intelligence works, we can more clearly understand the breakthroughs and innovations Deepseek has made. First of all, there are 3 stages to training an AI: pre-training, supervised fine-tuning, and reinforcement learning. Everything I have explained so far was the most important and first stage, pre-training. But don't worry, the basic logic of the other stages is very simple. Do you know where the term transformer, which also appears in ChatGPT's name, comes from? In fact, AI systems convert existing words into vector mathematics, just like what you see on the screen. This allows them to understand the relationships between words much more clearly. For example, you give it the words, "Today the weather is cloudy, so," and it continues your sentence by completing it with, "It will definitely rain." When ChatGPT first came out, you couldn't ask it questions the way you do today. Instead, you would give it a half-finished sentence, and ChatGPT would simply continue it. For you to be able to ask questions, large language models need to go through a second stage that we call supervised fine-tuning. In this stage, the AI is given prompts along with a massive dataset containing how a real human would answer those prompts. AI systems trained with these prompt and response pairs learn to use human language in a more specific way that is command-oriented or question-answer-oriented. Even though an AI that has passed through these stages learns how to generate possible answers, it still cannot understand which of those many answers is actually the better one. At this point, the third stage, reinforcement learning, comes into play. This stage is carried out either with human users or with a more advanced AI algorithm, but the logic is the same in both cases. The AI you have trained generates multiple answers to the question you ask, and then human users or a more advanced AI score these answers and tell the AI which one is better. This way, the AI we are training learns which answer is more useful. Most AI systems that exist today have gone through each of these three stages. And this is actually the biggest problem. Each of these stages is extremely expensive and extremely time-consuming. OpenAI has spent billions of dollars so far just to be able to perform these stages. This is where the difference of the R1 model, which shook the American stock market, becomes important. Deepseek almost completely skipped the second and third stages, yet still showed that it is possible to train an AI as capable as O1, ChatGPT's most advanced model. First of all, Deepseek did not bring this model out of nowhere. It was developed thanks to another model they released in December 2024 called V3, and that model works with different methods. When you ask ChatGPT a question, all of the 1.8 trillion parameters believed to be used in training GPT-4 start working at the same time, and the model produces an answer using this system. But when you ask Deepseek a question, its entire brain does not work at once. Instead, it uses its brain in separate parts, and each part is specialized in answering different types of questions. In this sense, it is much closer to how our own brain works. Each of these parts is called an expert, and since the model acts like a mixture of several experts, these models are called mixtures of experts. The V3 base model that Deepseek used to train the R1 model consists of 671 billion parameters, which is roughly one-third the size of ChatGPT's brain. But because this brain is divided into experts, only 37 billion parameters activate for each prompt and generate the response. And this response is just as successful and accurate as ChatGPT's O1 model. So how is this possible? To achieve this, Deepseek asked many questions to the model they called V3. They wanted this model to generate multiple answers to each question and also to produce a chain of thought, explaining step by step how it generated each answer. Of course, this model, which had not gone through the second and third stages we call supervised fine-tuning and reinforcement learning, initially could not produce very successful answers. But Deepseek developed a method called relative group policy optimization to overcome this problem. In this method, the AI is first introduced to a scoring system, and then it scores its own answers based on their correctness and whether they match the desired format. This is exactly where Deepseek's greatest contribution to the AI ecosystem is discovered during this training process. The AI realizes that the more time it spends on reasoning before answering questions, the higher the scores its answers receive. Therefore, as can be seen in the graph provided in the Deepseek R1 paper, it begins to give increasingly longer answers with each round. There is so much that human intelligence can learn from artificial intelligence. Look carefully and examine this part. What do you see? Let me give you the answer without keeping you waiting. What you're seeing is a moment around the middle of Deepseek's training, when the system realized it needed to check its steps before giving an answer. In the chain of thought text, it literally writes, "That's an aha moment I can flag here." I'm not joking, this was written by an AI, not a human. So far, we've seen only one extraordinary achievement of Deepseek, but the second one is even stranger and more astonishing. After completing all these training rounds in about 2 months, they end up with a new model called R10, but they notice it has 2 major problems. The first problem is that the AI produces its answers in a format that humans can hardly understand. The second problem is that it mixes English and Chinese in its responses, with some words in Chinese and others in English. Although this seems like a mistake at first, the researchers noticed that when they forced the AI to answer only in English or only in Chinese, its performance dropped significantly. In other words, by mixing multiple human languages, the AI achieves a more efficient reasoning system. This is exactly how the R1 model developed. The artificial intelligence wars that will continue in the future seem likely to proceed at a very high speed. See you in the next video.